Hey, this is Shri. Welcome all to today's session of Microsoft AI Search. And within Microsoft AI Search, we see something called a vector search. So, before we proceed to what vector search is, let's ask ourselves a question. What is the importance of vector search? Why is it needed? So, in real life, when you are creating an OpenAI application, you ask LLM something and LLM gives you the response, LLM being the large language model. But large language model is trained on a corpus mostly from all the public information available. Let's say it might not know the context about your organization's data. So typical examples include how does it know if you are introducing a brand new product into the market and you are in fact looking to use large language model in the context of the new product. So by the time this LLM was trained, there will not be any new product. What if your organization have some specialized information wherein your end users will get more context um, if you were to use the specific terms within your own corpus. So for that, you need to actually append a lot of your organization's information to the end user question so that you can use the large language model in the context of completion to give you a meaningful response within the paradigm of your data stores and within the paradigm of your company's data. So this we call as retrieval augmented generation or RAG, right? So this is the typical RAG pattern where vectors have more significance to them. So in the context of the RAG, then if we all agree that vector plays an important role, where does it play such an important role? It plays important role in order to search and retrieve the relevant information from your own data sets when a question is asked in a much faster and efficient way than the traditional similarity algorithms work. So to understand that, we have to see um, how actually like searching on a vector is different than the traditional algorithms. Though I might not explain in this session about the importance of different algorithms and why we might need those, what I will tell in quick 30-second pitch to you is if I were to say that um, if I ask a question on, let's say, hundreds of thousands of different entries within a data store, and only want to get, let's say, like top 5 items or 6 items that are very similar to that. Mind though, they don't need to be perfect, like some kind of approximate reasonable enough top six results back so that I can append that as a context to my end user before asking an LLM model. Then I will rather use the new paradigm of searching vectors if the promise of oh, it is so fast and you get the information very fast. Please take my word for that. The answer is true. So what is this elusive vector? So a vector is nothing but a value um, that is present in an n-dimensional space, um, that could be represented, a value that could be represented in an n-dimensional space based on certain characteristics. For example, let's say you have a text of 10,000 words, and if I were to represent the 10,000 words in an n-dimensional space, n-dimensional space, Like, um, for example, um, you know now we are not talking about two dimensions, we are talking about n dimensions, right? So the point is, I don't know how to draw the third dimensions. Humans cannot visualize more than three dimensions, but let's for simplicity talk about um, three dimensions. In three dimensions, let's say, if I were to convert a big paragraph for simplicity into a value in a three-dimensional space, this is that value, right? So that's that value in a three-dimensional space. So in order to represent that in a three-dimensional space, I need to have three values, right? Also, let's say, if I were to actually ask a question saying that, what are all the different points that are very similar, right? Or in this case, what are all the different paragraphs that are very similar to this paragraph in an n-dimensional space? If I want to retrieve them, then I need two things, right? So I need vector representations of all of these dots. And let's say, um, from this dot, I'm interested in these other two. So since this other two has a vector representation, then if I were to say that, okay, if I have a measure saying that this vector v1 is very similar to vector v2, and vector v1 is also very similar to this vector v3, so then I am covered, right? Then v1, v2, v3 are similar to each other. However, it is very difficult for us to visualize all of these vectors and what I'm talking about in an n-dimensional space. So let's actually talk a little bit about the two-dimensional space, and you will definitely understand. So let's actually see this notebook, wherein I want to show you. I'm just plotting 3 points. So I'm saying point one is 1 comma 2. um, Again, 1 comma 2 is, it is in magnitude 1 in a given direction and magnitude 2 in other direction. Negative 1 1 and negative 1 negative 1 uh, on a 0 0 coordinate system. So with that said, if I were to plot that, so this is my 0 comma 0, and they are going like this. So now, based on just by looking at them, you can say that, for example, uh, blue and green are never similar, right? Are almost not similar, because they're orthogonal to each other. So in a sense, blue and red might be similar. They are 180 degrees to each other. Doesn't mean that, if, for example, if you make a very small transformation to blue, still it might be similar to red, right? So something like that you can say, but you don't need to do all of that. There are very solid measures that we can take a look at too, and see what they are. There are actually two things we need to do. The first thing is, let's actually see these four sentences, right? So dogs are cute, therefore adopting a dog. I'm just talking about dogs. Then I am talking about domestic animals as pets, right? And I am hypothesizing, or I am advocating cats seem to be wonderful, blah blah blah. Then I'm talking about a very different thing. Sports are good, and children iconize Tom Brady and all other things I'm talking about. Um and and also in the French, like, more or less I'm talking, I'm sorry, I cannot speak French, but using translated, I translated something about dogs in French. So now, given again, if I were to say to you that, if I were to represent all of these four paragraphs into a set of numbers, and that set of numbers, uh, let's say in this case belong to 1536 dimensions. We cannot have infinite dimensions, so I'm limiting myself to represent something like that in 1536 dimensions. Then if I were to have a measure, that measure how near they are to each other and how far they are from each other, then those measures are dot product, cosine, and Euclidean distance. These need not be the same, but I'm just saying, uh, potentially. Example, right? So you all know in vector algebra, right? In linear algebra, you find actually how close the two vectors are, how different the two vectors are by measuring a dot product between them. So for example, if two vectors are very dissimilar or orthogonal to each other, then their dot product is zero. So zero means very dissimilar, and any value between 0 and 1, and 1 is extremely similar, and anything between, right, measures a degree of similarity. Likewise, you can use the angle between the two vectors, the cosine of 0 uh, or cosine of 180 again tells the same story. Just take the magnitude of that, it is 1. That means uh, if you take cosine as a metric, 1 means they are very similar, and cosine 90, angle 90, 0, they are very dissimilar, right? And Euclidean distance, you all know from basic math. So given these things, so if I were to generate the embeddings, um, and oh, I'm sorry, so let me run this. Let me generate the embeddings, and I am using Azure OpenAI to generate the embeddings. I have an algorithm, and the name of the algorithm is text embedding ADA 002. This is the famous embedding algorithm. It always returns 1536 dimensions, and then you actually see the measures. As you can see, it is saying v1 and v2 and v1 and v4 are more similar, right? And v1 to v1, if you take, right, it's the same vector. They are exactly similar to each other, the dot product. So cosine is a reverse, right? So 0 means they are uh, cosine similarity. There are two things, like there's a magnitude, and this one is the angle. Cosine of 0 is 1. That means they are highly similar. Just to emphasize the concept, I mentioned this. If you understand this, let's jump now into how do we store the vector representations inside something called a vector database, and how could we actually use our query, right? The plain English text query, how could we convert it into a vector and actually perform the similarity search within the database and get, let's say, the top three or top two representations of the same text by searching the vector similarity. Now let's see what a vector database is. So Azure or Microsoft has Microsoft AI Search. So what you need to do is, if you go to your portal.azure.com, simply say search for something called AI Search, right? So within AI Search, I have one search service listed. So then, as part of the search service, you have something called search index. So Microsoft actually stores the vector representations in the backend, which are very transparent to you. So you don't need to worry about the database. And as part of AI search, they provide you the flexibility to create the index. So just go ahead and add an index, and you can add different fields. So at minimum you need a content field, and then you can it's yes, it's a string which is your content, and you need actually another field to represent that content as a vector. And the one that represents as a vector, the type of that is uh, collection of EDM uh, single. So let's say this is my vector field, and then as part of vector field, you can actually say dimensions. Since I said I will be using Azure OpenAI ADA algorithm, it is 1536 dimensions. uh, and then you can actually create a profile, and you have to do couple of things. You have to associate an algorithm. uh, that algorithm is used to vectorize whenever you are inserting something into this index. It will actually, like, use this algorithm to vectorize. um, so that algorithm, there are two kinds of algorithms available in AI search. One is HNSW, and the second one is exhaustive KNN. HNSW is a kind of an algorithm which falls in the class of ANN, which is approximate nearest neighbors. So if you are a data scientist, you already know what K nearest neighbors are. So the approximate nearest neighbors are like a better representation of the better representation of candidates in hierarchies, so that the nearest neighbors are such the most efficient and the fastest way possible. So you have to select HNSW, but if you have a small corpus, exhaustive KNN is okay. So you are sacrificing some accuracy for the speed. If the corpus usually for any enterprises will be large, and in most of the cases ANN algorithm, which is HNSW, is good enough. And then it has some parameters that you can adjust. Please know beforehand what to adjust if you are doing, but please leave them as default. And there are three similarity metrics that this supports: cosine, dot product, and Euclidean, which I have shown you in the simplistic sense what they are. So let's say use cosine, and then let's say save. So that actually will ask you to create a vectorizer. So you chose the algorithm. Now you need to tell, um, okay, well, I have an algorithm that I can retrieve the data from the vector database using such an algorithm. But how do in the first place I vectorize, right? So before storing, what algorithm or what service I use in order to vectorize the content. So, like I said, the Azure OpenAI is the one that I'll be using, and within Azure OpenAI, you have actually an algorithm called Text Embedding ADA 002, and I'm using API key to get an access, or you can even use other methods. And once you say save and save and save, you have this index field. You can have one vector, or you can have two vectors here. That's totally fine. So at minimum, please know how to do this. Already I have, as usual, created one for our demo using the fields. I have an ID, title, content, category, and I have two vectors, a title vector and a content vector. Of course, I am using ADA embeddings for both of them, as you can see here. um, so with that said, let's see some of the code of how we can actually store the data in this, and how we can retrieve and search based on this particular index. Um, so let's see some Python code. As usual, the code will be in the GitHub location, which I will share underneath the video. So anyone can code. Just try to understand the concepts, and please feel free to use this. Um, So what we have is, I have a sample file such as this. This is directly taken from one of the Microsoft samples. You have actually an ID, a title, the content, right, and then the category. So we are just populating all the awesome Azure services here, and give a brief description of each of that so that the user can ask a simple question on such kind of a service. So whoever created that, thanks a lot for creating this awesome file. um, so then, if we actually see, okay, first let's see. We never use, right, probably the Azure portal to create the index. So we need to programmatically create such an index. But now you already know how to create program, how to create in the UI. So it'll be easy for you now. When I say something for you to understand, it'll be easy. So for example, for a title vector, if, right, so this vector is of type um, collection EDM single, right? So field data type single. Both vectors are that way, right? And the vector search profile name is HNSW. If you see the profile name, it is algorithm of HNSW, and the same parameters that you have seen, and the measure is cosine. Yeah. Unlike what I have shown you before, when I was creating a search, um, when I was creating the algorithm, there was an ability on the web page, in the portal, to go and configure the backend OpenAI algorithm directly from there, from Azure OpenAI. So you can do that. Just for simplicity, in this code, I did not do. When I am hydrating this index in this code, in simplistic case, um, I am still using that. Instead of using, like the backend vectorizer from there, I just said generate embeddings, um, right here. And then, I generated the same embeddings with the same code, right? So this is a standard code, get a handle to Azure OpenAI client, and then, you provide an algorithm to that, and you get the embedding back. And when you're hydrating the index, use generate embeddings to hydrate the index. So not going much deeper into hydrate index, but let's see the actual results. So if we actually go to perform vector search, one of the important things I forgot to mention about is, just use the latest and greatest library. It just works fine. You don't need to do any pre release versions or anything like that. The algorithm that you need to, sorry, the library you need to use is Azure Search Documents. I used is 11.4.0, and it just worked fine for me. So when I perform a vector search, what I need to do is, I need to call this function. I'm calling this function called search vector. And in the search vector, I am providing two vectors, a content vector and a title vector. The content vector, yeah, is the vectorized version of the content, and the title vector is the vectorized version of the title. And then, if you see the definition of this, those are the vectors are those two vectors are meant to be searched, and what I need back from the index is the fields, namely title, content, and the category. And the name of the index is the demo index itself. So when I pass these parameters, it goes and performs the uh, um, vector search. In order to perform a vector search, first I need to give a vector to that. So my question, how can I host my website, I'm converting it into a vector again using the same Azure OpenAI algorithm. And then I'm just calling this function, and this function has the search. If you see the search, you have what to search, the vectors, the two vectors that it need to search, and the fields that get back. I'm not filtering on anything, but if you want to filter, you need to give it like that, the syntax, like it's Lucene like syntax: category, EQ, analytics. And query type, I'm just doing a semantic configuration. Semantic configuration is nothing but you can instruct the system to take the results and take the context in and perform something called re-ranking. And remember, semantic configuration has nothing to do with generative AI or anything like that. This is an advanced ranking mechanism, think of it that way. So today it's not important. Just don't worry about it. All you need to know is I am providing a query, I am providing couple of vectors to search from. I don't need to actually provide the um, I don't need to actually provide the query text alone, right? I can provide the query vector only, because when I am searching, I'm giving search the text as well as vector. You don't need to do that, right? This can be none. In that case, that will be a pure vector search, right? I think it is capital none or something like that. So in that case, it will be a pure vector search. If you just give the query and no vector, this one, if you filter out, then that will be just a text search. If you give both, just like how I have given here, it is called hybrid search. So please remember, a hybrid search is nothing but you are searching not only a vector, but you are also searching some text with the vector. So let me revert back all the code just to make sure no typos are here. So let me go ahead and run this particular file. So what you get as an output, yeah, what you get as an output is um, really the content, right? That is similar to what you asked for. The query is about, let's see, about hosting a website. So it shows Azure App Service related content. And you see the score here. And there is something called re-ranker score. This correspond to the semantic search. So for the vector search, it uses the EANN algorithm. Thank you for spending time with me today on learning how Azure AI Search Index works, and what are the algorithms that are used in order to hydrate an index. What are the steps involved to retrieve the datas back from the index, both by searching a vector field as well as a text field. Um, Also, we have seen what a hybrid search is, and how semantic search re-ranks. I'll do a separate video on the semantic search. With that said, thank you very much for spending the time with me today. You all have um, a very safe and healthy week ahead. Thank you.